When we talk about number families here, basically what we're talking about is we're looking at the different types of numbers. This is really a vocabulary thing, but we have to understand this vocabulary in order to be able to talk about what these different numbers are, how they behave, and plus it's just useful for communicating in terms of math. So all of the numbers that you have ever seen would be classified as real numbers. So we're actually going to be existing entirely within the realm of real numbers today. Now, the realm of real numbers, that is divided up into two pieces. One piece is the rational numbers. So if we talk about a rational number, we're talking about something that can be written as a fraction or as a repeating decimal here. So rational numbers, basically a way to think about it then is a rational number is a number that you can actually write out. You can write the number on your paper somehow. Theoretically, it could take a lot of writing to do it, but you can write the whole thing. Now, contrast that with irrational numbers. Irrational numbers are non-repeating decimals. You've actually seen some of these already. Of course, one of them is very familiar. What is an example of an irrational number? A decimal that doesn't ever repeat itself? Pi, yep. That's what most of us think of when we think of an irrational number. Pi is a great example. All right, now within these categories, we have two other categories we'll see. They're both going to be within the rational side here. The first is integers. And yes, notice the pronunciation, integers, not integers. An integer basically says that there's no decimal or fraction in it. A lot of people end up calling them whole numbers, but whole numbers are actually slightly different. That's the last of our categories. A whole number has no decimals or fractions, yes, but it also has to be 0 or higher. So whole numbers can be 0, 1, 2, 3, and so on. But the integers can also be negative. So when we talk about integers, that's what we're talking about there. Is we're talking about the whole numbers and their negative counterparts. Now, I want to take a look at some examples about what some of these look like. So here are some actual examples for each one of those. So you can see for irrational numbers. We'll start on the right side, the ones that's kind of solitary. We already talked about pi there. But the square root of 2, negative square root 5, square root 7, all of those, they're irrational because they're decimals that go on forever. A little hint on irrational numbers. An irrational number, unless it's something like pi, the most common one that you're going to encounter is the square root of a number that doesn't work out nicely. So like, if I gave you the square root of 9, we know that is 3. That is okay. That would not be irrational because it gives us a whole number. But if it doesn't give you a whole number, you're probably looking at an irrational number there, because those will always give us these decimals that go on forever. Now, on the rational side there, on the left side, for rational numbers, you can see lots of different examples. I got negative 1.93. It's a decimal. I can write it out, right? 0 is a rational number. You'll notice 0 also appears later as well, but it is rational. It's just that some of these others are subsections of it. So if it's going to... Actually, I'll come back to that part. All right, so then 15.8 repeating. Remember that little line above the 8 means that the 8 is repeating. Yes, that decimal goes on forever, but it's repeating itself. And so we can write it by putting that little line above it. 52, a nice pretty whole number, and 2/7, a fraction. We can actually write it as a fraction, therefore, yes, that is rational. Now the integers and the whole numbers, we already talked a little bit about that, how integers include the negatives, whole numbers do not include the negatives. And we were talking about 0 there before. Notice 0 is a whole number. If anything is a whole number, it is also an integer. Notice how this box is built within this box of integers. That's on purpose. All whole numbers are part of the set of integers. All integers are part of the set of rational numbers. So if it's an integer, it has to be a rational number. And if it's a rational number, it also has to be a real number. So you notice it's kind of this breakdown where you're kind of like nesting here. Whatever the most specific one is, it includes that and everything outside of it. Now, looking at this picture, can you have an integer that is irrational? Can you have an irrational integer? Well, an integer means it has no decimals, right? So, can you have an irrational number that has no decimals? Well, if you're not sure, think back to our definition of an irrational number. An irrational number is a number with a decimal that never ends or repeats itself. Therefore, actually, you cannot have an integer that is also irrational. If a number is irrational, it's just irrational and real. That is it. The integers and the whole numbers, they are all rational numbers over here. All of them. There are no subsets of irrational numbers that we'll ever be seeing.